Hello, and welcome back to Backer Breaks It Down. We are continuing to look at the vertex of a parabola, and we're going to focus on how do we write a quadratic function in its vertex form. Okay. So we've written quadratic functions before. We just did it in factored form because they gave us the x-intercepts. If they give us the vertex, then it makes perfect sense to write it in vertex form. So if the vertex, and remember the vertex is represented by h and k in vertex form, and one other point on the graph that's xy of a parabola are known, you can write the equation of the parabola in vertex form. So you just need the vertex and one other point. You want to start by substituting these four values into your vertex form. So that's where the function is equal to a times the quantity x minus h squared plus k. You are going to solve for a, and then you're going to write the equation using only a, h, and k. So let's take a look at two examples. So it says when Andre practices free throws at the park, the ball leaves his hand at a height of 7 feet. So that would be like the y-intercept there, and reaches the vertex of its trajectory 10 feet away at a height of 11 feet. So the 10, 11 is the vertex. Okay, so we know that h is 10, k is 11. Our one other point on the graph is the y-intercept. They told us it happened at the 7 feet mark, so 0, 7, which means x is 0 and y is 7. So I'm going to substitute these four values into my vertex form. So my function value, that's y, is 7. A is unknown. And then I have the quantity x minus h squared. So x is 0 minus h is 10, quantity squared. And then lastly, plus k is 11. So that's my substitution step. Okay, now I need to solve this for a. Now in order to solve for a, I've got to do some like straightening up here. Like this plus 11, I'm going to have to send it over to the other side. So I'm going to get negative 4 over there. And then I also want to be like, what's this? So what is 0 minus 10 quantity squared? So I'm going to do that math, and I got it's 100. So I just kind of cleaned things up a little bit, and then one more simple step, and I can solve for a. So that means I have to divide both sides by 100. So I get that a is equal to like negative 1 over 25. Okay. And now I'm ready to write my function. So when I go to write my function, x and y will become variables once again. So I'm going to have y equals, and my a value is negative 1 over 25 times the quantity x minus h is 10 squared, and then plus k is 11. So this is my function here. So let's check out another example. Okay. So number 3, it says write an equation for the parabola whose vertex is negative 1, 4. So that means h is negative 1, k is 4, and passes through 2, 1. So x is 2, y is 1. So the first thing we do is we substitute these into our vertex form. So I'm going to have that my y value, which is 1, is equal to a times the quantity of x, which is 2 minus h. H is negative 1, so if I minus negative 1, I'm really adding it. Don't forget the squared. And then plus k is 4. So I make the substitution, and then I'm going to simplify this equation. So I'm going to do two things. I'm going to subtract 4 from both sides. Okay, that's going to give me negative 3 equals a times, and then I'm going to do this math. So 2 plus 1 is 3, and 3 squared is 9. And then I simply need to divide both sides by the 9. And I get that a is negative 1/3. And then don't forget to write your function. So our function by equals, and then we have a is negative 1/3 times the quantity x minus h. H is negative 1, so it becomes positive 1. Don't forget that it's squared. And then plus k is 4. And that's our function. So we can write quadratic functions in vertex form if we know the vertex. And then one other point on the graph, we're simply substitute these values into our vertex form. F of x is equal to a times the quantity x minus h squared plus k. Solve this for a, and then write the function. And that's how Bakker breaks it down.